Alright, guys, welcome back to Biology Scope. We are going to get back into talking about the theories of natural selection. So, first, let's talk about Darwin's ideas. So, just like we talked about in our last video, Darwin began his voyage thinking that species could not change. But his experience on his voyage changed his thinking. So, variation of similar species among islands, fossil evidence, and geological events convinced him that evolution occurs. But he wanted to know how. So, this led him to develop his theory of natural selection. So, natural selection is a mechanism by which individuals that have inherited beneficial adaptations produce more offspring. Organisms with the best traits or adaptations will survive and reproduce. So, this is known as survival of the fittest. So, nature will select according to Darwin's ideas. So, when parents create a variety of offspring, nature decides which of those variations survives and reproduces and which do not. So, over multiple generations, organisms become more and more fit for survival and reproduction within their specific environments. So, here we have these gross bugs, and I've got a bug killer spray over here. So, there's a different trait is going to be created by a mutation. That mutation is going to help this bug here survive. So, since these guys are dying off, this bug is going to produce more offspring, which makes it more likely for the bugs to mutate and survive. So, there are four main principles to the theory of natural selection: variation, overproduction, adaptation, and descent with modification. So, let's talk about variation. So, the heritable differences or variations that exist in every population are the basis for natural selection. So, the differences among individuals result from differences in the genetic material of the organism. Overproduction. This is when that there is a struggle for survival. So, species tend to produce more offspring than the environment can support. While having many offspring raises the chance that some will survive, it also results in competition between offspring for resources. Adaptation. Now, sometimes a certain variation allows an individual to survive better than other individuals that it competes against. More successful individuals are naturally selected to live longer and reproduce offspring that share those adaptations. Next, we have descent with modification. So, over time, natural selection will result in species with adaptations that are well suited for survival and reproduction in an environment. So, more individuals will have the trait in every following generation, as long as the environmental conditions continue to remain beneficial for that trait. So, here we have a beetle population that experiences many years of drought that results in decreased food supply for the beetles. Now, all the beetles have the same chances of survival and reproduction, but because of food restrictions, the beetles in later generations are smaller than the pre drought generations of beetles. So, an example of this is that certain traits become more common in a population through the process of natural selection. So, here we have all four of our main principles. So, let's look at overproduction first in the top left. So, a tiger may produce many offspring, but not all of the young will survive due to the competition for resources. So, let's move over to variation in the top right. Some tigers may be born with slightly larger jaws and teeth due to natural variation in the population. All right, let's move down to the bottom left for adaptation. Tigers with larger jaws and teeth are able to eat shelled reptiles. So these tigers are more likely to survive longer and leave more offspring than tigers that can only eat mammals. So let's move to the bottom right with descent with modification. So, because large teeth and jaws are heritable traits, they become more common characteristics in the population. So, that's how all four of these characteristics can tie together for a species. So, natural selection acts on existing variation. So, natural selection acts on phenotypes, which is the physical traits, rather than on the genetic material itself. So, new alleles are not made by natural selection, they occur by genetic mutations. So, natural selection can act on traits that already exist. So, if a mutation gives bacteria an advantage in a particular environment, it will grow better than its non mutated species, and then it can increase in numbers that it is selected for. So, here's an example of this. So, a drought in one of the Galapagos Islands in 1977 suddenly reduced the amount of small, soft seeds that the finches there preferred. However, there were still plenty of large, tough shelled seeds. So, because the large beaked finches in the population were able to crack that large, tough seed, they did not starve. So, what do you think happened? Let's talk about what happened. So, a trait that was already in the population became favorable for survival because of the change in the environment, and thus was passed on to future generations. So, as the environment changes, different traits will become beneficial. But I want you to take note that with evolution, a trait that is an advantage today could be a disadvantage in the future. So here's some important points about natural selection. Individuals do not evolve. Populations evolve over time. Natural selection can amplify or diminish inheritable traits. And environmental factors vary from place to place over time, and a trait that is favored in one place may be useless or harmful in another. All right, guys, that is all I have for natural selection.